What's up, everyone? Welcome back. Patrick here. Moving on to the next question, still dealing with factoring. So we have to find the x-intercepts of these quadratics over here by factoring. Now, one thing I want to mention with these quadratics here, notice that they are all in the format ax squared plus bx. And so for all of these, we're going to be able to factor out an x. We're also, in some of them, going to be able to factor out numbers as well. But I just want to mention that because we haven't got to the point yet where we can factor a fully standard form quadratic. So for example, you're going to see in the next section, we're going to be factoring quadratics like this. We're going to be given something like, let's say, this, and it's going to factor into two brackets like that. Okay, but we haven't gone through this process yet. But we do know how to factor something in this format. That's what we've been covering in this section. Okay, so just want to mention that there's a lot more to factoring quadratics than just these kinds, but this particular video, we're going to be dealing with this case over here, factoring quadratics where that c value at the end is basically 0. There is no c value over here. Okay, so let's start off with y equals 3x squared minus 4x. Now, how do we find x-intercepts of anything? Well, we plug in 0 for y, because that's what the y value is going to be. It's going to be 0 for any x-intercept. So the way we would do that, we would plug in 0 for y. And now what we got to do is solve for the x values. Now, the way we do that is through factoring. So what can we take out of these two? Well, notice 3 and 4, there's no factor in terms of the numbers, but we could take out an x from both of these because it's common. We have an x squared and x to the power 1. Take out the lowest exponent, which is x to the 1. What would we be left with in the brackets? Well, we would divide this by x, which would give us 3x, minus divide this by x, we'd be left with a 4, like that. Okay, so from here, we can solve for the x values. We've done these kinds of questions in previous terms where it was already factored for us. So we know how to do this. We just basically had to go from here to here. So in previous sections, we've already covered this, so you should be comfortable doing this. Just in this section, we're doing a preliminary step of going from here to here. Okay, and as we know, once we're here, basically we find the x values that make both brackets equal to 0. So it's going to be either x is equal to 0 for this bracket, this x value that's alone, or 3x minus 4 is equal to 0. And when we isolate for the x, we end up with 4 over 3, like that. So those are the two x-intercepts of this first quadratic right here. And in fact, this x is equal to 0. Whenever you have a quadratic in this kind of format, I've mentioned this in previous videos as well, one of the x-intercepts is always going to be 0 because you could always take out an x, okay, from these two expressions. Right, there's always going to be this single x term over here. Sometimes there's a number in front, but that doesn't make a difference. X equals 0 still ends up being an x-intercept. So x equals 0 is actually going to be an x-intercept for all of these because you're always going to be able to take out an x. So that's another thing that I wanted to mention. Okay, so for this particular one, the two x-intercepts are 0. And then 4 over 3, we won't get into too much detail with graphing. If you want to do a quick graph, I'm not going to find the vertex and stuff like that. If you want to practice that, feel free. 0, 4 over 3 is like 1.33, so let's say that's like right here. And then it's a positive a value, so we know it's opening up. So it ends up being a quadratic that looks like that, where we got 0, 4 over 3 right there. If you want to find this vertex, you want to practice that algebra, you can. We've already done a bunch of videos where we did that. Remember, you add up the x-intercepts, divide by 2, so you'd get what, 4 over 6 for the x value over here, which simplifies to like 2 over 3. And then if you wanted the y value, plug in 2 over 3 here. And then that would be the coordinates of this vertex over here. Okay, but again, I'm just gonna be focusing on finding the intercepts, and I'll draw a quick rough graph with the intercepts and look at whether the quadratic is opening up or down. Okay, so that's the first quadratic. Here we got, again, same thing, we plug in 0. For y, now we got to solve for the x value, so we could factor. Notice from the 2 and the 6, we could take out a 2, and then we could take out an x as well. So what would we be left with here? If we divide this by 2x, the 2's cancel out, x to the 2 over x to the 1 would give us x, plus this divided by 2x, we'd end up with a 3, like that. All right, so we end up with 2x times x plus 3. We're solving for x values that make the y value equal to 0. And so from here, we got to figure out, when is 2x going to equal 0? When's x plus 3 going to equal 0? Well, over here, it's just x is going to be 0. That's why it doesn't matter what's in front over here, because when you divide it by that value, you're going to be taking 0, dividing by that value, you're going to end up with 0 over here, no matter what number is there. So that's why x equals 0. It's always going to be an x-intercept for these. Over here, isolate for the x is -3. Right, that's the other x-intercept. It's opening up, so if you wanted to make a quick rough graph, we got 0, we got -3, and it opens up like that. Right, so the x value of the vertex is going to be at -1.5, the midpoint between the intercepts. If you want the y value of the vertex, plug in -1.5 into for the x value and get the corresponding y value. Okay, and then finally, part C, same thing, plug in 0 for y. Now here we got -x squared minus 4x. Whenever there's a negative in front, I like to take out a -1. Now sometimes it could be like, let's say we had maybe -3x squared minus 9x. Okay, notice that in this case, we could take out a -3, right? Because 3 and 9, common factor is 3. And because there's a negative here, I take out the negative. And so we'd be left with, we could take out a -3x. I could also take out an x, so we'd be left with what? X plus 3. Like that. Okay, but here we got a 1 and 4. And there's no common factor, there's no number we could take out of that besides 1. So we're just taking out a -1 because of this negative. Right, but sometimes if there's something like this, for example, I still take out a negative because there's a negative in front here, but then I look at the numbers, 3 and 9, we could take out a 3, like that. So just wanted to mention that. I could have maybe even added that as an example. Actually, maybe I'll add it at the end there quickly. So I take out a -1 here, and then also an x, right? So dividing this by -x, we'd be left with positive x, and basically just the signs change, like that. Right, -4x divided by -x gives us +4. And then you can check your answer factoring back in -x squared minus 4x. That's what we end up with. And then to find what x values make this 0, when does -x equal 0? Divide both sides by -1. That's going to happen at an x value of 0. When does x plus 4 equal 0 for this bracket? That happens when x is -4. Right, so those are the 2 intercepts. And by the way, you can always check your answers. That's another thing I forgot to mention. You could take these, plug them back here for the x value, see if you get a y value 0. If we plug in 0 for x, 0, 0, that gives us a y value 0. If we plug in -4, we'll have -4 squared minus 4 times -4. This would be -4 to the power 2 is +16. -4 times -4 gives us +16. -16 plus 16 would give us that y value of 0. Same thing with these. You could plug them back into the original, to make sure you're getting that y value 0. So that's a nice way to check. And then if you were to graph this roughly, we got 0 for x, -4 for x. Those are the two intercepts. But here we have a negative a value, so we know this quadratic is opening down. So it's going to be in that kind of format. If you wanted to get the vertex, the midpoint, -2, so this would have an x value -2. If you want to get the y value, plug in -2 here. Should be a positive y value, as you could see from the diagram there. And yeah, that's roughly how the graph is going to look. If you're doing these and you want to check how the graph looks like maybe in Desmos, it's just going to, I feel like, make you more comfortable with quadratics and knowing how everything works. And let's, as I mentioned, let's quickly do, let me just add this extra one here. Let's maybe do, I don't know, -2x squared plus 10x, like that. Okay, same thing, 0, -2x squared plus 10x. Now, because there's a negative here in front, I'm definitely going to take out a negative. 2 and 10, we could take out a 2, and then we could take out an x as well. So dividing this by -2x, notice -2 divided by -2 is +1. X to the 2 over x to the 1 would give us just x. Dividing positive 10x by -2x, x's cancel out. Positive 10 divided by -2 would give us -5. Like that. All right, so this factors into that. You could do a quick check. If we distribute, we would end up with -2x times x gives us -2x squared. -2x times -5 would give us positive 10x. So from here, when does -2x equal 0? That happens when x is 0, right? Divide both sides by -2. Here, when does x minus 5 equal 0? When x is equal to +5. So those would be the two x-intercepts. Here, if you want to check your answer, 0 is very easy to check. Obviously, it's going to make the whole thing 0, but 5, here we would have +25 times -2 would give us -50, plus 10 times 5 would give us +50, -50 plus 50 would give us 0. And then how it looks, we would have 0, +5, those are the two intercepts. It's a negative a value, so it is opening down. Like that. All right, so notice how a quadratic in this kind of format, without a c value, it's always going to go through the origin. All of these went through the origin. That makes sense. The y value, the y-intercept is 0 as well, because that's the c value, and the c value is 0 over here. All right, so all of these are going to go through the origin. Sometimes the x-intercepts will be on this side. Sometimes they'll be different shapes, but it's always going to go through that origin 0 and 0. Okay, so that's the process of finding x-intercepts, these kinds of quadratics with factoring.